All right, guys, this is going to be our second lesson for this week, and this time we're going to be covering surface area of pyramids and cones. So yesterday we started with our surface area of prisms and cylinders. Now we're moving on to pyramids and cones today. All right, so let's jump into some essential understanding. We have a lot of vocabulary here we need to cover. So to find the surface area of a three-dimensional figure, find the sum of the areas of all the surfaces of the figure, kind of what we did yesterday. A pyramid is a polyhedron in which one face, or the base, can be any polygon, and other faces, which are the lateral faces, are triangles that meet at a common vertex called the vertex of the pyramid. All right, so again, yesterday with our prisms, we saw that the lateral faces were rectangles. For pyramids, the lateral faces are going to be triangles, as I said there. You name a pyramid by the shape of its base. So again, whatever the shape of the base is, since there's only one base in a pyramid, that's what it's going to be called by. So in that first example right there, it's called a hexagonal pyramid because the hexagon is the base of the pyramid, like the one below. As we see, that base is a square. That's why it's called a square pyramid. The altitude of a pyramid is perpendicular. Is the perpendicular segment from the vertex to the plane of the base. The length of the altitude is the height of the pyramid. So again, all stuff that we know there, and then these pictures show great examples of what it says there. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. Key vocabulary there. Remember, regular means that all sides are congruent in regular. Okay. Isosceles triangles means that there are two sides that are congruent. So again, the legs on those isosceles triangles are congruent. The slant height, or RL, is the length of an altitude of a lateral face of a pyramid. So understand that on the triangles, on the lateral faces there, the slant height goes from the vertex down to the base of the of the triangle there. Okay, so it doesn't go from the base from the base of the pyramid to the vertex. It goes from each triangle. That's what the slant height is. That's going to be important here for our surface area. And then in this book, you can assume that a pyramid is regular unless stated otherwise. So all of our shapes are going to be assumed to be regular unless they tell us otherwise. Okay. A lot of information there, a lot of vocabulary. Again, so here are kind of some formulas that we need to know for our pyramids. Okay, so the lateral area of a pyramid is going to be the sum of the areas of the congruent lateral faces. You can find a formula for the lateral area of a pyramid by looking at its net. Again, remember, a net is just a three-dimensional figure unfolded. So again, there's our base, and then there's our four isosceles triangles that went around the base. So our formulas that we're going to be using are pretty much the same formulas that we've seen before. The SA equals LA plus, this time it's just going to be 1B because there's only one base. So for pyramids, it's not 2B. That goes with prisms and cylinders. Pyramids are just going to be B because there's only one base. Okay, so lateral area is going to be a little bit different as well. All right, so with the lateral area of a regular pyramid, it's going to be half the product of the perimeter of the base and the slant height of the pyramid. So again, you need the perimeter and you need the slant height, and then you're going to take half of that. Okay, that's how you find the lateral surface area. And then to find the surface area, it's going to be LA plus B, not 2B. That's the difference here. So let's take a look at it here. Finding the surface area of a pyramid here. So what's the surface area of this hexagonal pyramid here? So our first step is make sure that we are writing down our formula here. So our formula, like we said before, is SA equals LA plus B. We only have one base. That's why it's B. Okay. So the first step we need to solve for is our LA. Like we just said, that LA is going to be 1/2 PL. And remember, L is our slant height, okay? So we're first, the easy thing for us here is find the perimeter of the base. They give us one of the side lengths on the base, and remember, all of our bases are going to be assumed to be regular. So if that's the case there, that base right there tells us that that is 6 inches. So all the sides around are going to be 6 inches, and there are 6 sides. So to find perimeter, it's going to be 6 times 6, which equals 36. So there's our P. The L is our slant height. So again, I'm looking at the lateral faces, trying to go from the vertex to the base of our triangles, and it should be perpendicular. And as I see there, they do give us the slant height. That's that 9 inches right there. So our L is 9. So to find our LA, it's just going to be 1/2 times 36 times 9. All right, so 1/2 times 36 times 9, that should give us, what, 18 times 9? Which is 162. So our LA is 162. And then we're going to find the area of our base here. So again, anytime they give us a regular base, again, we have our formula we can always use. All right, so to find the B, that area is 1/2 apothem times perimeter. Luckily, we already saw for our little p. We know that the little p from our previous one we used was 36 right there. Now we're looking for the apothem. Again, remember, the apothem is regarding to our base. So the apothem would go from the vertex, and then it should go to a side. It won't go to another, it won't start from the center, and it's not going to go to a vertex. It's going to go to the side. So again, looking right there, that little 3 radical 3 right there shows us that from the center point there to a side is 3 radical 3. So there's our apothem right there, which is 3 radical 3. So when I rewrite this now, it's going to be 1/2 3 radical 3. And the perimeter, as we said before, was 36. Okay. So we have 36 times 3 times 3. Take half of that. And then multiply. Since it's not saying leave it in radical form there, we're going to put it in decimal form. So I'm going to multiply that 24 times radical 3. All right. So then I got 41.57-ish. Right, and then I'm going to add that, because that's my B. I'm going to add that to my LA, which we said was 162. So plus 162. And that should give us right around, I got 255.5. There we go. Okay. So let's take another look here. On example 2, now we're just looking for the lateral area of a pyramid. All right. So remember, for our lateral area here, that's not our LA plus 2B. So we are just looking for the LA. So if we go back to what our formula is for LA, LA should be 1/2 PL. So again, we're looking for the perimeter and we're looking for the slant height, okay? So looking at the information that they gave us there, they gave us the base right there. So I can find the perimeter. Again, we're going to assume that all of our bases are regular, which means all the sides are congruent. So the perimeter of my base, that P, should be pretty simple to find. It's going to be 30 times the number of sides, which is 4. So that should be 120. Okay. Now I need to find my slant height. Unfortunately, they did not give me the slant height. So what I have to do is I have to pull that triangle out right there. So I'm going to pull that triangle out right there. So here's my triangle. We know that the altitude is 36.4. And again, we're looking for the slant height. So this is the X that we're looking for right there. Okay. So for us to find that slant height right there, we have to use the information that's given to us. So again, if that C that we see right there in that triangle, that's the center point to our base right there. So if a full side length on our triangle right here is 30, then half of that, because that's the center, half of that's going to end up being 15. And remember, this is a right triangle. So now knowing that I have 2 out of my 3 sides, I can use Pythagorean theorem here to solve for that X. So all I'm going to do here is go to my calculator. I'm going to type in 15 squared plus 36.4 squared. Get a big number there. I got 1549.96, and then take the square root of that number. And it should give us right around, I got right around 39.37. 39.37. So there's my slant height right there. Again, we found our 120 from our perimeter. Last step, just plug everything in. So I have 0.5 times 120 times 39.37. And that should give us right around 2,362.2. Okay, so there's our pyramids. All right, we're going to go ahead and move on to the second part today, which is a cone. Okay, so it's a lot of vocabulary there for what we've seen. All right, but it's kind of the same concepts that we've seen. All right, but here are the formulas. That's the most important part that I wanted to get across to you guys. Our lateral area, so to find the lateral surface area, it's going to end up being 1/2 times 2 pi r L. Which again, since we're not really we have that 1/2 and that 2, that actually simplifies down to pi RL. Okay, 1/2 times 2 is just going to end up being 1. So 1 times anything just is itself. Okay, so our formula that we're going to focus on is that pi RL right there. So just like before, for our pyramid and our cone, that surface area should be the same thing there. Overall, right, since there's one base, our formula is going to be SA equals LA plus B. There's only one base. That's why it's 1B. Okay. So knowing this now, let's go ahead and take a look at our first example here of finding the surface area of a cone. Okay. So again, I'm going to write out the general formula here. SA equals LA plus B. All right. So first step here, let's find our LA. So again, if I go back to that same formula that we just learned there, LA equals pi RL. That's our formula. Okay, so we're looking for the radius and we're looking for the slant height here. If that's the case, the radius of our base right there is 15. And the slant height, as we see, is 25. Now they want this in terms of pi, so I'm going to leave it just as it is. So I'm going to multiply 15 times 25. So 15 times 25 gives me 375 pi. There's my LA. To find the area of the base, that's our circle. So to find the area of a circle, it's just going to be pi r squared. Our radius here is 15, so it's going to be 15 squared. So 15 times 15 gives us 225 pi. And my last step here is to just add those two numbers together and leave pi at the very end since they want it in terms of pi. So all I'm going to add here is 375 plus 225, and that should give me 600 pi. Okay. All right. This will be our last example here. So now we're just finding the lateral area of a cone. Okay, so remember, first step, write your formula. So for a cone, it's going to be LA equals pi RL. Okay. So for our example here, what we're looking for is the radius and we're looking for the slant height. So what they gave us here, they gave us the diameter. So again, for our cone here, our radius, our diameter is 80. So knowing that our diameter is 80, then I'm going to use half of that for the radius, which should be 40. So I know that my R is going to be 40. And unfortunately, they did not give me the slant height here. They gave me the altitude. So what I have to use here, I'm going to draw a right triangle here. So here's my right triangle. We're looking for the slant height, right? We know that the altitude right there is 45. And then the radius, as we said, was 40. So again, if I have two sides and I'm missing a right triangle, I'm trying to find the third, I'm just going to use Pythagorean theorem. So I have 40 squared plus 45 squared. And I get a big number of 3,625. I'm going to take the square root of that number. So the square root of 3,625. That should give me a decimal of 60.21. So we know that that slant height, that L, is going to be 60.21. All right, so from here, now that we have that part, we're going to multiply those two numbers together. So that times 40. And again, they did not say that they wanted in terms of pi. So what I'm going to end up doing here is multiplying that times pi. So times the symbol of pi. Again, if you are not sure where that symbol of pi is, it should be right above your little caret button right there. So you hit second caret, and then you should see the pi symbol there. Okay. And again, once you've done that and you multiplied it out, you should get a pretty big number here. So then the LA should equal 7,565. And we're going to round it to the nearest, I don't know, tenths and say 0.9. And that is millimeters squared. Right. All right, so that's going to sum it up for us there, guys. All right, just to give you guys a heads up, our homework will be due tomorrow at Thursday at 11:59 p.m. So that gives you today and tomorrow to get that complete. Remember, virtual office hours will be today from 1 p.m. to 2 p.m. And again, if you have questions, as always, feel free to contact me. You know I'm here for you guys. All right. Other than that, guys, stay safe, and I hope you guys are getting your work done. Y'all be safe.